In this short video, I'll be taking you through how to answer question 1, the map skills question from the IGCSE Cambridge Geography exam that was taken in March 2021, and the question paper was 22. So the aim of this video is to show you how to complete this particular question in the exam. It offers hints and tips of how to approach these questions, and really you can either follow and complete as we go using the links to download the PDF of this particular exam question, or you can use it to help you practice other exam questions. Now the reason this video has been made is because really paper 2, map skills, there's not a lot of variety in how the questions are asked, and therefore it's a very good question that through practice you can aim to get as many marks as possible. It is worth a big chunk of this exam. And by a big chunk, it's worth 20 marks out of a possible 60. Also, these questions are compulsory, and so you should aim to spend 30 minutes out of the possible 90 on this question. And just so you know that this question is generally made up of, has links to the assessment or rivers parts, themes, and it can dip into a little bit of coasts or tourism. Now, for this question, you will need the following equipment: a protractor to work out bearings, a ruler to help you with the 6-figure, distances, maybe even to help you draw lines to work out other questions, the cross-section of the map, pencil and a sharpener, and a rubber. A calculator would also be useful. Now, before starting the exam, there are 2 things you should do on the map itself. The first thing is to draw a compass, a 16-point compass with the various bearings written on. So take a little bit of time to do this. So you start off with north and south, with north at the top and 180 degrees at the bottom. Then you draw the east and west line, again with 90 and 270. You then put in the northwest and southeast, so 135, 315. If you're unsure, just add 45 between 90 to 90. And then likewise the northeast line at 45 degrees, and so southwest would become 225. Now you also need to know the direction in between, for example, north and northeast. Now to work that out, you always start with the smallest, the single letter, in this case north. So with these additional points, the first one would be north, northeast. So you start off with the single letter, and then you add on the 2 letters. So again, between east and northeast, it would be east, northeast. And then you keep on going, adding them in. Now remember, this time you're going to add 22.5 degrees every single time. Another useful thing is to highlight, circle, or find out the scale of the map. Usually they're at the top, and they can also be underneath the map as well. So in this case, the scale is 1 to 25,000. That means 1 centimetre on the map is 25,000 centimetres in real life, or 1 centimetre is 250 metres. Another common scale would be 1 centimetre on the map is 50,000 centimetres in real life, or 1 centimetre on the map is 500 metres. Now once you've got that and you've highlighted it, and you've maybe write down that 1 centimetre is 250 metres, you also need to highlight and find out the contour line interval. And that's really important when it comes to doing things like finding out the difference in heights, describing the relief, or drawing across a section. In this case, the contours are 10 metres. So there's 2 things highlighted in red are the things you need to find out. Another useful thing to do, this might be a little bit extra, maybe a little bit extra for you to do, particularly if you've already drawn the compass, is that once you've orientated yourself, and 9 times out of 10, north is always at the top of the map, it might just be useful to actually, around the map itself, to write which sides are north, east, south, and west. And again, it's just those 3 things: drawing the 16-point compass with its bearings, working out the scale and contour line interval, and then maybe doing this. It's a useful thing before you start getting the exam, just to calm down, to make sure you have as much information as possible to start this paper. Okay, so if you've been looking at my other videos, you should know that most of these exam questions all start off in a very similar structure. Usually it is requiring you with this map extract to work out what the various features are. So here's the first question from this exam. So the first thing I'll get you to do is draw on, the first thing to remember is that the map extract and figure number have the same dimensions. And also draw the outline of figure 1.1 onto the map to focus your attention. What I mean by point 1 is that if you measure the distance with a ruler between point 85 and 86 on figure 1.1, that should be 4 centimeters, which is also the same distance on the map. So let's move on to identify these features. So there is A, that road. So again, I'm looking for that, that feature, that's that whole black line. So remember, figure 1.1 is a simplified version of the map extract. So I'm looking for the whole feature of A. We've got B, C, D, and E. So let's try and work what these various features are. And again, you use the key, which can be found at the bottom of the map. Okay, so let's get answering these questions. So there is feature A, is that long orange line. Generally, that probably signifies it's a road, so I'm going to look at the key. And then remember, okay, it's a main road. It looks a bit like the second one. Okay, so I'm going to, yeah, that has to be a main road. So remember the order in which the symbols appear, the same in which the key that explains to you what it is. So I'm going to write main road. Next one is the name of the river B. So I'm going to follow that blue line all the way down or up until I come across a name. And there it is. Second one is land use at C. Okay, so let's identify the woods. And so C is this coniferous woods. Write that. Feature D is this little map symbol. Okay, and so if we look at that, that is a leisure area. So again, the order in which the symbols appear is the same in which the explanation is. So I'm going to write leisure area. And then the height above sea level of the spot height at E. So there is my spot height. So again, that shows you the height above sea level. I'm just going to copy down that black number, and that is 1,150 meters. Remember that figure because it's going to be quite useful for a question coming up. And let's check the answers. Brilliant, all correct. Okay, another common question on this. Generally speaking, this comes with also working out the bearing, but in this particular case, we just need to look at the compass direction. And here it is. So for this, we need our handy protractor and the compass with the bearings that we drew at the start of the exam. So we need to plot the 6 figure references. If you're unsure how to do that, please do look at some of my other videos that I've done of how to work out the 6 figure grid reference. And so there's the first point and there is the second point. So once you've drawn and found those 2 points, you need to work out the start point. So I'm going from the river outside at 863 and I'm going to the junction with the footpath southeast. So that my start point therefore is in grid square 8601. So that's where I'm going from, and I'm going to the point on top of the hill. And so after I've worked out the from and start, I'm going to draw a straight black line between the two and then draw a little north arrow pointing upwards on from my start point. Now this question might be the time that you think about investing in a 360-degree protractor. If you do not have one of those, please follow on to work out to find out how I calculated the 360-degree. So I've got my compass with the 16-point compass, and the line was 135 degrees. I worked out 315. How did I get that? Well, my protractor says 135 degrees, but there are 360 degrees with bearings, so we need to add 180 degrees, because again, it's a reflection. So 135 plus 180 equals 315 degrees. And that is exactly northwest. Now, yes, on your compass it would say NW. I would prefer if you write out northwest, because sometimes it's given and sometimes it's not. But if you write out northwest, they can't take the point away. And there we go. Even the mark scheme requires you to write northwest. So just to show you what to do, remember, divide up the route into as many straight parts as possible, measure and add them up, work out the scale and times them together. So your answer should be between 1,350 and 1,650. If I was to do that, these are the various straight parts I would use, and then I'll get my ruler, measure them out in centimeters, and then times that answer by 250 meters. And hopefully my answer should be between there. Give it a go. Now this next question, it's a very, very rare question that comes up, looking at actually calculating the difference in height between 2 points. As well, this would form part of another question that again is incredibly rare, and that's working out the gradient of a slope. So what I'm going to do is show you how to calculate this question, and then if you want to, continue watching to work out how you calculate the gradient between 2 points. So here, I've circled my starts and endpoints. I now need to find out clues to tell me the height around these areas. So what can I do? I'm looking for spot heights, contour lines, or even different colours to show me that. Luckily on this map, there are lots of spot heights that are very close towards my start and end points. So I'm going to use those. I need to work out the highest points, which in this case is 1,152, which is very close to my end point. And the lowest point, which is close to my start point, is 1,039. So with those two measurements, I'm going to take them away, and I should have a difference of 102 meters, which is one of the answers above. So I'm going to circle that and then check it against the mark scheme. Now, like I said, if you want to continue watching to find out how to calculate the gradient of this slope, please do. If not, skip to the next chapter. So how do you work out the gradient of a slope? Now, to remember, the gradient is a measure of how steep a slope is. The greater the gradient, the steeper the slope. So this little formula here is something that's very useful. The gradient equals the vertical height divided by the horizontal distance. So remember, the vertical height is the difference between the highest and lowest points, and the horizontal distance, in other words, is the straight line between these 2 points. So my vertical distance, we've already calculated that. It's the change in height from the start and end points, which in this case is 102 meters. The horizontal distance, again, is the straight line distance between these 2 points, which if I take my ruler out, measures at about 4.9 centimeters. And so if my scale is 1 centimeter equals 250 meters, I should get a distance of, a straight line distance of 1,255 meters. So if I return to this formula, I know my vertical height is 102. I know my horizontal distance is 1,255. So if I divide that answer, I get 0.813. But for a gradient, I need to write it as a percentage. So times 0.813 by 100. And that gives me an answer of 8.1%. So please, if you're unsure how to do that again, just rewatch the video and try. And if you do find past papers, please tell me which ones they are and put them into the chat so I can do a little video to help them explain. But for the ones that my students done, I haven't seen them for a very long time. Okay, so another common question is you get given a small area, usually 2 grid squares or 2 different grid squares, and you have to compare the 2. And from that, you have to decide if certain features appear in either square, both of the squares, or none of the squares. So really, you need a key for this and take a little bit of time. So for the first one, I'm looking at parking, and for that, I need this line of the key. I'm looking for the blue P. There's a blue P in one of the grid squares and in the other one. Therefore, I can put a tick here that they are present in both of these areas. Next one, I'm looking at steep slopes. So I need to find any evidence within the grid squares where these lines are close together. In the top left of the grid square, the contour lines are very close together, and also in the bottom, in the south of the grid square, they're also quite close. Grid lines in the other grid square are quite far apart, so really I'm going to say that is just the first one that has steep slopes present. Area liable to flooding. Well, let's have a look at what the key is. Okay, so I'm looking for a sort of dotted blue line, so I need to find that on my map. I have an area in the first grid square and a very small area. That's why I need to be particularly careful in the other grid square. So from this, I can tick both these areas. And for the next one, land over 1,200 meters. So I'm looking for contour lines or spot heights that are above 1,200 meters. I'm going to first start with some spot heights, and if I can't find any, I'll look at the grid squares. But luckily, there is a spot height here that is above 1,200 meters in the first grid square, and in the second one, again, this one shows clearly that it's above 1,200 meters. So I can tick that both these areas have land over 1,200 meters. And then for the final one, I'm looking for the symbol for a church. So I need to find any of these symbols that you can see there, and I cannot. So I'm going to tick that neither of these areas have a church. And if I check my mark against the mark schemes, yep, all correct. So again, with these questions, take it nice and easy, making sure you study each grid square carefully. Another difficult question is looking at the cross-section of an area and identifying features along it. So the first thing to do on your map is to measure that distance, which in this case is 12 centimeters, sorry. And then I find the points, the grid squares on my map, and where exactly I have to draw the line and double check that that equals 12 centimeters, and it does. Next stage is quite simple. If I take my ruler and I measure it along with 0 at the left, I can see that at 4.8 centimeters, I need to find out whatever feature A is. If I go to my map, that is a blue-orange road, so I'm going to write main roads. For the next one, I'm going to put my ruler against it, and I know that's 9.5 centimeters. So again, along my line at 9.5 centimeters, there is a blue body of water. So I'm going to either write a perennial body of water, or the lake, which is what it is, or the name of that lake. And that should be enough to get me the mark, and in fact it does. Okay, now to draw the cross section. So as I said there, work out where the centimeters of where you need to draw are, i.e. the gap that's missing. So point 1 can be found at 5.7 centimeters, and point 2 can be found at 8 centimeters. And so I need to draw every single contour line and mark that on there. But in this particular case, if I have those 2 points marked on my ruler, you can see there are an awful lot of contour lines going between these 2 points. So what I want to work out is, and that's quite hard to draw on, so I'm going to look at what the general trend is. And generally, they all go uphill to just below 1200 meters. And so I'm going to draw that onto my thing, going up there to 1200 meters. Now, I've got some other examples that you can check out on my videos that explain how to do the cross-sectional areas that are a little bit more tricky. So please do check them out. So some of these questions require you to use the map extract to describe the site and give reasons for the growth of a particular settlement. And so first of all, it's useful to, before you start thinking of different reasons, think about what type of settlement it might be, and also what do you mean by site, what do you mean by situation, and why would a settlement grow. If you know all those, please wind forward a few minutes to when I talk about the answer. If not, please carry on watching for a few minutes while I go through and answer each of those 4 points on your screen.
So knowing type of settlement is really important in being able to work out some of the factors that affected the size and situation of the settlement, pretty much why a settlement has been built there. Dispersed settlements are the ones where the houses are spread apart over a very wide area, like an image that you can see in the top, and you're looking at the map below. Generally, they tend to be homes of farmers, and they tend to be found in rural areas. And so in these areas, settlements tend to be in remote or mountainous regions. The land is predominantly used for agriculture, and there are very much limited job opportunities, which pretty much explains why a settlement perhaps hasn't grown into a much larger one. Second type is linear settlements. These are ones that are built along lines. For example, geographical features such as a lake, a shore, a river, or a road. When linear settlements follow a road, the road often came before the settlement, so they were built there to sort of use that as transport links. Other type of settlements, the final ones, nucleated settlements. These are where houses are grouped closely together, often around a central feature like a church, crossroads, or a particular industry. New settlements tend to have this pattern, and they tend to be found in areas that have flat relief, because it's easy to build on, maybe at bridging points, very defensive position, a good water supply, and no restrictions to develop in any particular direction. So, what do you mean by site? Pretty much the site is the land upon which a settlement is built. There could be lots of different reasons for this, such as a wet point, there's a presence of water, or it's dry, it's high up, it won't flood. Particularly flat land makes it easy to build on, or it's a defensive site. Or maybe it's protected by a hill. There might be fertile soil, might be trading aspects, resources, accessibility, easier to get access to other places, or as a bridging point across a river. It doesn't have to be all of these, but certainly some of them. And again, you will need to be able to look for evidence of these on your map. So how can you see these factors on a map? Well, wet points indicated by river, streams, or lakes. For example, here, you can look for that in the key. Dry point defensive site, well, look for contour lines. High on a hill pretty much implies that it's defensive, or if it's a nice flat plateau. Fertile land and natural resources, check on the key if there's a colour, or look for the symbols such as farm. Natural resources, woods, minerals, stones, mines or quarries, and you can find these symbols on the key or map. Trading point accessibility, pretty much look for roads, rivers and railways. Bridging points, just look for the symbol. Whereas the site refers to initial reasons why people decided to build the settlement at a specific location. So for example, they wanted a defensive position close to a wet point with some trees. You can also think about the function of that town. It might give you an indication. If it's near the sea, it's probably a port. What's the reasons for that? Is there a quarry nearby? So it's probably a mining town. So the situation then refers to how easily the settlement can access other natural resources and attract peoples to its location. So the situation of a settlement will determine whether the city can grow because the settlement can grow to become a large city, or if it will stay as a small town or village. So why did it originally locate there? Why could it grow?
Okay, so back to the question. I'm going to say something on the lines of the site was influenced by the flat land at the bottom of the valley as it makes it easier to build on. It was also built away from the river to avoid flooding. In terms of the reasons for growth, I might go on to say something like the settlement could have grown as it is on a road junction and close to a river which could provide water. As well, the footpath indicates that it could be on a tourist trail. So I've got lots of points there, and if I'm going to compare it against the mark scheme, I can see, yep, it's influenced by the bottom of the valley. It's an area away from flooding. Goods is on a road junction, it's close to a water supply, and it's a footpath which could indicate tourism and things like that. So any of those 4 points would do, and in fact I have more than enough.